Most people have probably seen a juggling act at some time during their life, but it is less likely that while watching it, that they ask themselves about the math involved in juggling. Well, those people are missing out. There are in fact lots of ways in which mathematics could be linked to juggling. I could talk about formulas that link the duration of throws to the number of balls to the number of hands. Or I could talk about the parabolas formed by the balls thrown by a juggler. But I'm not going to talk about either of those things. One of the most interesting links between mathematics and juggling has to do with juggling patterns. More specifically, how can you express a juggling pattern mathematically? Imagine that you were juggling to a fixed beat, and that while juggling, a ball is caught and released on each beat by alternating hands. So, theoretically, the time when a ball lands and when it leaves again is the same, like this. The method to notate juggling patterns which we use is called Siteswap. To start out, we will only focus on basic notation, called vanilla Siteswap. This means that on each beat, there is at most one ball in a hand, and also that throws alternate hands. Obviously, the higher we throw a ball into the air, the more beats that ball is going to stay in the air. So depending on the height each ball is thrown, and therefore the length of time it stays in the air, we give each throw a different number. So, we're juggling to that fixed beat again. Imagine we decide to do a 3 throw. In this video, the only throws I'm doing are 3 throws. What does this mean, and what does it look like? Well, it means that from the time the ball leaves our hand a first time, to the time it leaves a second time, 3 beats will have passed. We can represent this using a useful diagram. So this is what the Siteswap diagram for a 3 throw looks like. An n throw is a throw that is thrown again n beats later, or more simply, the only throw you do while juggling n balls. So if I'm juggling 3 balls, all the throws I'm doing can be described as 3s, because after each ball is thrown, the same ball is thrown again 3 beats later. We can see this better when juggling with colored balls. But if you still don't understand, don't worry. We're going to go through each of the basic throws individually. A 0 throw means that there is not a ball in your hand in that beat, so you don't do anything. This is a diagram for a 0 throw. A 1 throw means that you pass the ball from one hand to another, so that you throw it on one beat and throw it again on the next beat. This is the Siteswap diagram for a 1 throw. A 2 throw means that you throw a ball up so that it lands in your hand 2 beats later, and you throw it again 2 beats later. But since this isn't very useful, a 2 throw usually just describes holding the ball in your hand for a beat. This is its diagram. You're probably wondering why a 1 throw crosses hands, but a 2 throw stays in the same hand. The reason for this is easy to see if we look at a Siteswap diagram. Remember that one of the rules of vanilla Siteswap is that throws must alternate hands. So if we draw a Siteswap diagram, each beat will represent a throw coming from a different hand. So, if we draw a 1 throw, it goes from one beat to the next, meaning that it changes hands. However, if we draw a 2 throw, it will skip one beat. This means that it will land in the same hand as the one it came from. A 3 throw means that a ball will land in the opposite hand 3 beats later. Also, as we have seen, a 3 throw will be the only throw you do while juggling 3 balls. This is what the Siteswap diagram for a 3 throw looks like. If you hadn't already guessed, a 4 throw means that a ball will land in the same hand, but 4 beats later. And, predictably, a 4 throw is the only throw you do while juggling 4 balls. Finally, here's what a 4 throw looks like in a Siteswap diagram. From here on, it's pretty easy to guess what the other throws are going to be like. So let's take a basic example. How could you write down this 3-ball pattern? It's easy. all you have to do is take the throw that occurs on each beat and write it down. This one is pretty easy. Since we already know that for a basic 3-ball juggling pattern, the only throws occurring are 3s, this pattern will be 3, 3, 3, 3, 3, 3, 3, and so on. But since this pattern continues infinitely, we write it as a series of numbers that if repeated would create the entire pattern. So for this one, just 3. But I'm sure you guys want a harder example. How would I write down this pattern? What would its site swap be? Maybe if we slow it down a bit, it will be easier to pick out a pattern. Okay, from this point, let's try to pick out each of the individual throws. Okay, as we just threw a throw that's not crossing hands with the yellow ball, that's probably a 4. That was pretty quick, but what just happened was a 4 throw with the red ball and a 1 throw with the blue ball. I'll play it again so you can pick that out yourself. Okay, from this point the pattern just repeats itself. So this pattern is 4, 4, 1. 4, 4, 1. Now that we know that this pattern is 4, 4, 1, we can write it down in a site swap diagram. So, just like in the video, there's a 4, 4, 1. 4, 4, 1. Okay, now that you've got this basic pattern, let's try to do another pattern, but this time let's have a 2 in it. If you remember, a 2 is a throw that isn't really a throw because it stays in the same hand and you don't throw it. Let's look at this pattern. What would its site swap be? So there, we just saw a 4 throw from the yellow ball. But wait, the blue ball just came from the same hand as the last throw. But since throws alternate hands, we have to look to see what happened in the other hand. It was just holding a ball. But because of the alternating hands rule, we have to take note of that, as a 2 throw. Then we can record that a 3 throw was made with the blue ball. From here, this pattern is just going to repeat itself. So we can see that this pattern is 4, 2, 3. 4, 2, 3. Remember that the 2 means that the hand is just holding a ball. So here's the site swap diagram for 4, 2, 3. What we need to remember is that although the 2 looks like a throw in the diagram, it just translates into us holding the ball when we are actually juggling the pattern. 4, 2, 3. 4, 2, 3. Okay, for extra fun, do you want to do a pattern that includes 0? I'm sure you do. Look at this pattern. Okay, let's slow it down a bit. So there, we just threw a high throw crossing hands, a 5 throw. Wait, the throw with the blue ball came from the same hand as the throw before it, so again we need to look at the other hand. Unlike last time, however, there was no ball in that hand, so it was a 0 throw, not a 2 throw. If we look again at that video, we see that there were actually 2 throws, a 0 and a 1, not just a 1. From there, the pattern just repeats itself. So this pattern is 5, 0, 1, 5, 0, 1, 5, 0, 1, 5, 0, 1, 5, 0, 1. So, this is what the site swap diagram for 5, 0, 1 looks like. What's confusing about this one is that you have to look out for the 0. There's a 5, and then wait, we skip a beat. That's the 0. 5, 0, 1. Now that you're already pretty good at Siteswap, we can go deeper into the maths behind it. One area of this is how do you check whether or not a pattern can be juggled. Juggling diagrams are one way of doing this. For example, if we take the pattern 4, 2, 3 and draw its Siteswap diagram, we're going to see a number of things. First of all, we see that it can be carried on infinitely, and also we see that on each beat, at most one ball is caught and thrown. But however, not all patterns are like this, and not all patterns can be juggled. For example, the Siteswap 2-1 is not juggleable. We see from the diagram that you need to catch 2 balls at once, which isn't possible in vanilla Siteswap, and also that you would need one ball to disappear when you catch it and then reappear in the next hand. From this we can extract a very important rule, that to check when original siteswaps can be juggled from this diagram, make sure that on each beat one line ends and another begins, or that no liner begins or ends. In this case, the beat must be a zero throw. But drawing diagrams takes too long. Luckily, there's also an algebraic way of determining whether a siteswap can be juggled. To do this, we need to find what is called the test sequence. So first, you basically add 0 to the first term, 1 to the second term, 2 to the third term, and so on. Once we have this, then we need to divide each term by the total number of terms in the siteswap, a number which we call the period of a siteswap. Finally, you have to take the remainder of each of these terms. So here's what taking the test sequence of 4, 2, 3 would look like. First, you add 0 to the first term, 1 to the second, and then 2 to the third. Then you have to divide each of these by 3, which is the total number of terms in this sequence, the period. Then finally, to find the test sequence, you need to take the remainder of each of these. So for this sequence, 1, 0, 2. So let's take the test sequence for 2, 1. We've already seen that this pattern cannot possibly be juggled, but what will its test sequence look like? Its test sequence will be 0, 0. So, can you guess how a test sequence tells us if a siteswap can be juggled? Basically, if all the numbers in a test sequence are different, then the original siteswap can be juggled. However, if there is more than one number which is the same, the siteswap cannot be juggled. From this rule, we are given two ways in which we can play with the numbers of any juggleable siteswap. The first important deduction that we can make is that any term in a siteswap can be changed by the period, and the siteswap will still be juggleable as long as the new term is not negative. For example, 4, 2, 3. This siteswap has a period of 3. So if we add 3 to 2, the second term in 4, 2, 3, we get 4, 5, 3. What we're going to see is that 4, 5, 3 actually has the exact same test sequence as 4, 2, 3, meaning two things, that it is juggleable and also that the test sequence has not changed. This is because if you add 3 to something being divided by 3, the remainder will still be the same, and so the test sequence will still be the same. The second implication from the test sequence rule is that any two terms in a juggling sequence can be swapped as long as you add 1 to the term moving left and you subtract 1 from the term moving right. This is incidentally where the name siteswap comes from. So you have m, n, and you change it to n plus 1 and m minus 1. We can show why this works using the example of 501. We already know that this siteswap is juggleable. Basically, you are just swapping two terms in the test sequence, so there will still be no two terms in the test sequence that are the same. So here we see that the test sequence of 501 is going to be 2, 1, 0. Now let's apply the swap to 501. We move 0 left and 5 right. We get a new sequence of 1, 4, 1. So we're calculating the test sequence of 1, 4, 1, and what we're going to get is that two terms in this test sequence have switched. It becomes 1, 2, 0, and is still a valid siteswap. These swaps are also interesting because we find that any siteswap that is juggleable can be turned back into a constant juggling pattern that uses the same number of balls as that original siteswap. So we're using the swapping pattern. We start with 501. We swap 1 and 5 to get 1, 4, 1. We take 1, 4, 1, and then we swap 4 and 1, and we get 1, 2, 3. We turn this around so it's 3, 1, 2. We get 3, 1, 2, we swap the 3 and the 1, and we end up getting 2, 2, 2. So the constant juggling sequence is 2. Another implication of this is that any siteswap can be created by permuting a constant juggling sequence. So, like we just saw, you can create 501 starting with just 2's. Besides how you can test if a siteswap is valid, which we've already seen, another interesting question is how do you find the number of balls used in a siteswap? One way to do this is to draw a diagram and then look at the number of lines between beats. This works because between beats all balls must be in the air, so the number of lines will equal the number of balls. For instance, Here what we're going to see is the Siteswap diagram of 4, 2, 3. And when we draw a line in between two beats, we're going to intersect with 3 of the lines that are going through the air, which represent the balls. So 1, 2, 3. We see that there are 3 balls used in this Siteswap. However, there's a much easier way to find the number of balls. Just take the average of the terms in the Siteswap. For instance, 4 plus 2 plus 3, all divided by 3, is equal to 3. So this pattern uses 3 balls, if we've seen. As a rule, the number of balls in a Siteswap that can be juggled can be found by taking the average of the numbers in that Siteswap. We can show why this works using the method of permuting a Siteswap so that you get a constant juggling pattern, just by using swaps. It is easy to notice that for any constant juggling sequence, the average and the number of balls are the same. For example, 3. Take 3, divide it by the period, which is 1, and you get 3 balls used. Now, what happens next is going to rely on 2 previous rules that we have learned. First, any Siteswap can be created by permuting the constant juggling sequence with the same number of balls. For example, 3 can be permuted to create the juggling pattern 4, 2, 3, which also has 3 balls. Secondly, the average of a pattern being permuted never changes, as you are adding 1 and subtracting 1 from the total simultaneously, giving a total change of 0. So, we can deduce that for any Siteswap, the number of balls is the same as its average.